Hello, in this video lesson, we are going to begin our unit on evolution. And keep in mind that evolution is simply this idea that things have changed over time. Things don't mean to change. Things don't say, oh, I want to change. Most of evolution is due to mutations. And when something has a mutation, sometimes the mutation is immediately bad. And nature knows it's bad, and nature knows it needs to get rid of it. But sometimes a mutation might make a creature have a neck that's a little bit longer. So nature waits to see, okay, well, what happens? And that having that longer neck lets that creature reach leaves that are higher up in the tree, so that creature is more likely to survive in certain areas, hence the giraffe. So this is this idea that things change over time. And most of the time, things change due to mutations. And the nature's going to sit there and watch those mutations. Nature's going to select what it likes and what it doesn't like, which is how Darwin came up with this idea that we call natural selection. But those will be talked more about in different videos. This video is pretty much going to focus just on where it is believed the Earth and early life came from. So from earth science or from middle school science or even elementary school, you probably heard of the Big Bang Theory. Well, the Big Bang Theory is the idea that something somewhere exploded and things got shot out into space, and just due to gravitational force and things spinning around, we ended up with these balls, and that's what formed our planets. Well, in the case of early Earth, geological evidence shows that Earth was formed about 4.6 billion years ago, but it was very, very different than Earth today. And keep in mind, a lot of what we know about our planet is now based on studies of what we can see happening with these massive telescopes when we look at other universes and other planets. But a lot of what we know about the early Earth, we base on the study of volcanoes, volcanism, and the study of magma and the gases that come out of a volcano and the gases and the particles that we find in magma. And it's believed that this is how our planet actually started. We were just this ball of molten rock, which is what magma is. So a lot of what we base our idea of early Earth on is what happens when a volcano explodes. When volcanoes explode, they give off very, very toxic gases. And that's why a lot of times when you see volcanists, scientists who study volcanoes, they have air supply with them because there's a lot of toxic gases that can come out of a volcano. And a lot of people that are in areas where volcanoes erupt, a lot of times they don't die because they get burned. They die from the chemicals that fall from the sky and the toxic gases that are given off. And so based on what we know about volcanoes and when volcanoes explode, it's believed that our atmosphere in the very beginning had almost no oxygen whatsoever. It's believed that we had a lot of hydrogen, a lot of methane, ammonia, just like Mr. Clean, and water vapor. And again, this is based on what we know about the atmosphere when volcanoes explode. And this is a picture. You know, you can think of this as when Earth was first forming. It was incredibly hot. So you have the magma and you have the cold rock cooling on top of it. And it was so hot, it was too hot for liquid water. So any water that was there evaporated into water vapor form. But over time, we're talking many years, over time, the Earth began to, the Earth was spinning, and so we had wind patterns. As that atmosphere built up, it formed wind, and that atmosphere, as the atmosphere builds up, it helps cool things down. And it was cold enough that rocks could actually form. And at this point in time, the surface was still covered with volcanic activity. And so magma was constantly exploding, the lava would come out and cool. So the Earth's surface was constantly changing. And it's believed about 3.8 billion years ago, the world had cooled down enough that we could actually form liquid water. So we had oceans, we had thunderstorms. But honestly, these oceans probably were not like the oceans we have today, because the way that the reasons that our oceans are salty is due to millions of years of eroding away rocks and the earth, and that puts salt into the water. So when our oceans first formed back 3.8 billion years ago, they probably were not oceans like we think of today. They might not have been salty. They might not have been pure water. There were probably a lot of other really toxic chemicals in them. So life as we know it today probably could not have lived in this water that first formed 3.8 billion years ago. But the question has always been, okay, well, where did life come from? You know, we have water, and we believe that life started in water, but you know, we had these massive thunderstorms. There was no oxygen in the atmosphere. There's a lot of toxic gas in the atmosphere. The water, who knows what was in the water? So this gentleman, his last name was Operon, and he's not on this PowerPoint, but this gentleman, okay, Dr. Operon, some people say Operon, okay, I might have spelled it wrong, I will admit, because this is just coming off the top of my head. Dr. Operon was a gentleman who actually studied volcanoes, and he came up with this idea behind how the Earth might have formed. And he talked about, you know, by studying volcanoes, the gases that come out of volcanoes and the hot liquid magma, and just by watching lava come out of a volcano and watching how that lava cools and forms, you know, igneous rock. He wrote a book talking about how he believed the Earth could have formed. However, he never did any experiments on it. So in the 1950s, these two gentlemen, Dr. Miller and Dr. Urey, took Dr. Operon's book, read that book, and figured out, okay, how can we take that book and turn it into an experiment? And it's now obviously called Miller and Urey's experiment. Basically, they set up this self-contained glass tubing. And down here, this represents the oceans at the time. Now, the world was still really hot. So it's very possible that that ocean was incredibly hot, maybe even to the point that it was boiling. But we know when things get hot, we make steam, and that steam rises and joins our atmosphere. So the other glass bubble that they had represented the atmosphere. And when they were putting these together, they put in this atmospheric bubble the gases that were believed to have been in early Earth. So they would have had hydrogen, methane, ammonia, again, water vapor. And then down here, they did put water with a little bit of salt in it because we don't really know much about the ocean. They were just assuming that this is what it was like. And they basically allowed it to run. So they boiled the water here, and the water got hot and it formed water vapor. And you know that water vapor rises into the atmosphere. And as it rises into the atmosphere, it can condense and form rain. But the way that they had this self-contained, they had it hooked up to a battery. And this battery, as you can see here, the wires for the electrical current, this battery simulated lightning. And this is how, you might have heard of ozone. Sometimes people say, oh, I can smell a storm coming. Well, lightning can actually cause a reaction with ozone. And so you can actually smell that. So we know that lightning is just like you stick something in an oven and heat it up in order to bake it. Well, we know that lightning, the electricity in lightning and the heat in lightning can cause chemical reactions and can cause things to change. So what they did was they created like this model of early Earth. They had an ocean, they had an atmosphere, and then they sparked it. They had lightning go through it, and they left it for a very, very long time. Some of their experiments are still running because the question has always been, all right, where did that first cell come from? Where does life come from? What they were able to show us in their experiment is over time, and this is actually a model of their actual experiment. Right here, this is what represents the ocean, and up here, you're representing the atmosphere, and you can see he's demonstrating adding the electrical charge to it in order to create that lightning effect. And over time down here, they would notice things began to collect. And we're talking about a lot of time. This is not something that just happened overnight. But over the period, and some of their experiments, like I said, are still running today. But over a period of time, remember when they put this together, there were none of these things in there. But over time, amino acids have begun to form. And remember, amino acids are what we need in order to make DNA and RNA, our genetic material. Sugars have formed. And remember, sugars are what we need to make that gasoline called ATP. And just recently, nucleotides have started to form. And again, amino acids are formed proteins. That's totally my fault. Amino acids are needed to form proteins, which basically make your cells your cells. And the nucleotides form our DNA and RNA, our genetic material. Now, we don't have cells yet. We haven't formed DNA yet. But this, again, this experiment is simulating millions of years of time that has passed. But in this experiment that has been running since the 1950s, we are beginning to see how the building blocks of life could have formed. And so Miller and Urey showed that mixtures of organic compounds, remember organic means it contains carbon, necessary for life could have been created on primitive Earth. Well, put that aside, we're looking at history. And early ideas on where life came from, some people had this idea of what's called abiogenesis. Remember, A meaning without, bio meaning life, genesis means to begin. It's also called spontaneous generation. This was the idea that life could just be produced from non-matter. And a classic example is the fly and the rotten meat. Now, you and I all know that when meat goes bad, it starts to stink. And we know that flies are attracted to the smell of rotten food. And the flies will crawl over the meat and they'll lay little eggs. And their eggs are so small we can't see them. And when the eggs hatch, they hatch as larvae, which are maggots. Well, we know that because of this concept. Okay? Back in the day, people really thought that the smell of rotten meat turned into flies. That's where flies came from. This is this idea that we call spontaneous generation. So this gentleman called Francesco Redi said, nope, we can't have this spontaneous generation. That's not true. So he set up two jars. In one jar, he put meat and he covered it. And remember, this was back when they didn't have refrigerators. You know, we're talking in 1800s. So, or even maybe even earlier. And so they didn't have the refrigerators, so they had to eat the meat pretty fast or it would go bad. So he put one piece of meat in a glass jar and he covered it. Then he put another piece of meat in a jar and he left it open. Well, over time, the jar that was left open, the flies were inside the jar. But the jar he left plain, or the jar he left covered, there were still flies, but the flies and the maggots were all on the outside of it. There were no flies and maggots inside the jar. He's like, look, if the meat was turning into the fly, there would be flies inside the jar. But remember, back then, people did not want to believe, science. And this was shot down. And then came a gentleman named Louis Pasteur. Louis Pasteur, you might know his name because go look in your refrigerator. You will see pasteurized milk. Well, pasteurized milk is sanitized milk. And it comes after this gentleman, Louis Pasteur. Louis Pasteur basically disproved the idea of abiogenesis. He showed that you have to have life to make life. He is who we call the father of sanitation because he boiled things. Now, we now know that heat kills bacteria, it kills viruses, so we wash, our dishwasher uses boiling water. If you hand wash your dishes, you're just washing the dirt off of them. You're washing the food off of them. You're not sanitizing them. You're not killing anything because you are not using boiling water and you're not letting those dishes sit in that boiling water for at least 30 minutes. Watch your dishwasher. Look at how long it runs. Look at how hot it gets. But Louis Pasteur believed that heat would kill little bad creatures. So he took chicken broth, soup. You've all had chicken noodle soup, and he boiled it. And by boiling it, he was killing any of those little creatures that was inside the soup. Now, if you take chicken soup and just leave it on your table, over time mold will start to grow. It will go bad. It turns a dark green color, it gets cloudy. Well, what he did was he made this special little funky flask and he boiled chicken broth. And over time, he just let it sit. And as you can see here, nothing grew in that chicken broth. Down here, once he broke it open, things started to grow because what we actually found, or what he actually proved, was all based on the shape of his flask. Okay. Over time, you know that things evaporate. Well, as they evaporate, they rise to the surface, they will cool. That's what condensation is. Well, when things condensated, like little drops of water, they would either flow back down into the flask or they would flow into this little crook right here. And that little crook got quite nasty because anything that entered the tube there would find basically the remains of chicken broth that had dripped to that area and was perfectly happy. It would never crawl up to the other parts of this experiment. And things couldn't just fall into the chicken broth. Well, we know here, once we broke the stem, things could fall into that container and cause bacterial growth, mold growth, things like that. So he proved what we call biogenesis. This is the idea that living things come from other living things. This is now part of the cell theory. Cells come from cells, but the question has always been, where does the first cell come from? And that's what Miller and Urey's experiment is trying to show. But based on what we know about early Earth, we believe the first cells were probably heterotrophic, which meant they fed off of things. They were anaerobic. There was no oxygen in the environment, so they didn't use oxygen. And they were prokaryotes. Remember, if you're a prokaryote, that means you do not have a nucleus, and you're automatically called a bacteria. Now, fossils indicate that about 200 to 300 million years ago, cells similar to modern bacteria were common. Isn't it kind of cool that we can find fossils of bacteria? As the Earth changed, we began to, and just through mutations, we began to make bacteria began to show up on Earth that had this really cool mutation in it. And that really cool mutation in it allowed them to harvest the sun's light. So at some point in time, photosynthetic bacteria evolved. At some point in time, we started on Earth forming oxygen. So oxygen could begin to form in the atmosphere. Now, the rise in oxygen did cause some life forms to go extinct, but others evolved ways to use oxygen for respiration, which you remember respiration is where you take sugar and you use oxygen in order to make ATP. Okay. Oxygen continued to build up in the atmosphere, and as lightning storms continued, it made ozone. And you know that the ozone layer helps protect us from UV radiation, and that allowed even more complex organisms to evolve. Until eventually we got cells that we know it today. And we do have this belief of what we call the endosymbiotic theory. Endo means inside, symbiose means a partnership. So we actually began to believe that prokaryotic cells may have begun to involve internal cell membranes, which is the ancestor to eukaryotic cells. Some people believe with the endosymbiotic theory is that a smaller cell went inside a larger cell and formed a partnership. And this is where a lot of people believe the mitochondria and the chloroplast came from.